Okay, so let's look at these first two questions here. It says the table to the left shows the year and population in millions of Texas. Use an exponential model, write an equation for the curve of best fit, then estimate the population of Texas in 2020. Now, personally, and a lot of times when you run into questions like this, it will also have something like, say, use t equals 0 for the year 1900. Okay, so that's what we're going to do. We're going to say that this is 0 for 1900. So 1920 would be 20, 1940 would be 40, 1960 would be 60, 1980 would be 80, and then it wants us to estimate in 2020, so what would we plug in that case? 120, because that's 120 years from where we started. Typically, it will give you those instructions. So, it's been a while since we've done anything like this, so in case you've forgotten, we need to go to Stat and Edit. When you do that, make sure that List 1, List 2, and List 3 show up. If they don't, then that means one of them has been deleted, and you need to go back to Stat, and at the bottom it says Setup Editor. You press Enter and press Enter until it says Done, and then you should be able to go back to Stat Edit and see all three of your lists, okay? So in List 1, we put 0, 20, 40, 60, and 80. And then we put in our populations in List 2, 3.1, 4.6, 6.4, 9.5, and 14.2. Now, it tells us to use an exponential model, but before we do that, I want us to actually look at the scatter plot for this. But there are several things that we need to do. We need to adjust our window, and we need to turn the stat plot on. So let's go to window first, and let's make sense of what our window should be set to. Okay, X is your L1. So X's coordinate to your years. So we need to make sure that our window includes 0 to 80. So I'm going to go like -5 just so that I can see my y-axis. I don't actually need any negative times, but I do want to actually see that y-axis on my window. And then for my maximum, I'm going to go up to like, well, since we're predicting for 120, let's go ahead and go to like 125. Okay, go ahead and go to 125. I like to give myself a little buffer on each end. Let's talk about the y-values. The y-values are populations. We obviously don't need to worry about negative population, but I would also like to see my x-axis, so I'm going to leave that at -5. And then it goes up to 14.2 right now, but we're predicting for 40 more years after that. So, I don't know, like maybe 25, just to make sure I got enough room. Okay. Then we need to turn on the stat plot. So second y equals, we'll turn on plot 1. You can choose, we need a scatter plot. We don't need to change that. If you want to change what your little icons are, you can do that at the bottom, but you really don't need to. Then we need to press graph. Okay. So we can see that this has some curve to it. It's not going to be a straight line. You've done linear regression before, but these are not linear models. Okay, this has some curve to it, so that's why it wants an exponential model. So let's actually find that exponential model. Go back to your stat and over to calc. You've used the linear regression before, but you need to keep going down to 0 that says EXPREG. That's exponential regression. Press enter. Now I'm going to show you something. Don't press enter again yet. I'm going to show you something that you may or may not have seen before. I'm going to show you how you can store this model in your Y1. Okay, so you're going to press second 1. That tells it that the X values are coming from list 1, comma, it's beside your parenthesis. Second 2, that says the Y values are coming from list 2, comma. And the third thing we're going to put in is where we want it to store. So see this vars button beside the clear button? Okay, press vars. You go over to yvars and you press enter, and see they give you a list, y1, y2, y3. Okay, press enter because we want it to put the model in y1. So this is what your screen should look like right now. Exponential regression, L1, comma L2, comma y1. Does anybody need help finding any of those? Good? Okay, now we can press enter. So it's going to give us the same information that it's always given us. It's going to give us the model. It shows us that it's y equals a times b to the x. It gives us a, it gives us b. Now yours may or may not have that r squared and that r. I'll show you here in a minute how to get that on there. We don't need it right at this moment. But let's go ahead and write down our model. Let's say, I'm going to write this in function notation. I'm going to write P for population of T is equal to A 3.095. Okay, I'm going to give myself a few decimal places here, 3.095. Parentheses, my base is 1.019 raised to the T. Now compare this to the data. Remember what did this number in the front stand for? What was this number? The initial amount. Okay, that's pretty close to the initial amount that we had. We had 3.1 as the population initially in the actual data, so that's pretty close. But remember, it's a model. It's not going to give you the exact amounts. So press graph. After you've written that down, press graph because I want you to see how well this model goes through all the points that we had. It doesn't go through them exactly because it's just a model, but it should be very, very, very close to those points if it's a good model, okay? And let me show you how you can use this to predict, because this is going to save you from having to type in a whole bunch of decimals. If you press second trace, the very first option there is value. So if you press that, it will allow you to type in anything that you want for X. So we want to predict for the year 2020. We already said that should be 120. So type in 120, press enter, and look, it's going to use the exact model. It's going to use all those decimals. It's stored those in there. We don't have to worry about rounding or anything like that. So it gives us a really precise answer here for P of 120. We're talking about 29.7 million people. I rounded to 29.7 because that's how the table was rounded. They rounded to the nearest tenth. So stick with that standard. Yes, sir.
Let's do another way to equation.
Okay.
You go into everybody.
Uh-huh.
And then the product.
Uh-huh.
And then you go into statistics. And then go over to EQ and then
Okay. Thank you for sharing that. I didn't know about that one. Okay, so he's saying if you go, let's put it in Y2, you can press bars and go to statistics and over to EQ, regression equation. It will store it'll put the regression equation there as well. So there's two options there for getting that exact equation in there. Thank you for sharing that. Okay, let's do another one. The table on the left shows the closing prices for the NASDAQ stock index at the end of February during certain years. Using an exponential model, write an equation for the curve of best fit, then estimate the year the closing price will reach 10,000. So we're going to do the same thing. We're going to use 0 for the first year that they give us, 1992. So then 94 would be 2, 96 would be 4, 98 would be 6, and 2000 would be 8. So we go over to our stat, edit. Now, if you want to clear out what's in there, don't press delete. Scroll up to L2 and press clear and enter. Don't press delete. If you press delete, that will remove that entire list. Your L1 or your L2 will disappear. So 0, 2, 4, 6, and 8. And then type in 633, 793, 1100, 1771, 46, 96. What a jump right there at the end. Okay. Let's adjust the window because our years are a little bit different. We've got, I'm going to keep it a -5, but we only go up to 8. It says predict when it will reach 10,000, so I'm going to give myself a little bit of a buffer. I'm going to go to like 15 because it is starting to grow a lot faster, but it probably won't take a super long time to get to 10,000. The Y minimum, I'm going to leave that. The Y maximum, we've got to get all the way up to 10,000. So I'm going to give myself a buffer. I'm going to go to 11,000. Okay, I'm going to go to my Y equals. I'm going to clear out the regression equation that was already in there. I'm going to look at the graph, see that it's got that exponential curve to it. It starts out kind of slow and then it starts to take off. Let's find our regression equation. Actually, you know what you can do? You can press second enter as long as you haven't typed anything else in. It'll bring up what you typed in last time, and that's exactly what we need. We still need the exponential regression. Our data's still in L1, L2, and we want to put it in Y1. Press enter. So here is our model, P of T. Well, I don't really want to use P. P was for population. Let's say, well, we're talking about price. That works. The price at time T is equal to 518.185. Notice that's a little bit further away from our initial closing price. The base is 1.272 to the T. So there's our model. Let's look at the graph. It's pretty close to our points there. It doesn't go through them as nicely as the last one did, but not all models are going to be able to fit the data super, super well. Okay, let's, now, how can I figure out when this will reach 10,000? Anybody have any ideas? How can I figure out when this will reach 10,000? There are two different methods I'm thinking about. You can go to your table. Okay, you could. I wasn't thinking about that one at all. You could go to the table and look for, what are we looking for? Where the Y is 10,000. Okay, so we don't quite have a 10,000 exactly. We've got a 9,000 and then it jumps to 11,000. So we know it's somewhere between 12 and 13. So how could we maybe narrow that down a little bit more specifically? Any ideas? Okay, you could change your table set. You could, make this, instead of going every 1 unit, you could break that down so that you can see a little bit more detail. Any other ideas? I'm thinking of one algebraic way and one graphical way. We could put 10,000 into our Y2. And then what would we be looking for? That intersection point right there. That's one way to do it. The intersection of the two curves. So that would give us T is approximately 12.304. So let's see here. From 1992, that would be somewhere in the year 2004. Okay. Any other ideas for how we could have done that one? We could just set our equation equal to 10,000 and solve it using logarithms like we did on Friday. We could say 10,000. What do we do first to solve that equation? Divide by the 518.185. And then what do we do? What do we do after we get the exponential by itself? What's the next step in solving? Put it in log form. So that would be the log of 10,000. Not 10,000. The log of that number right there. 10,000 change because I divided by the log of the base. Pretty close right there. 12.303. Okay. So two different ways that you can approach that. You can use your graph. You can solve it algebraically. We know how to do both. All right. Now, the next two examples there aren't talking about exponential models. They're talking about logarithmic models. So it's the same idea here, but when you go to stat calc, logarithmic is number 9. Now, it has an ln, but ln is still a logarithm. It's what we call the natural logarithm. So it's number 9. So I want y'all to try and do numbers 3 and 4 there. I want y'all to try and do 3 and 4 using the logarithmic model.